We've done over 150 front-end interviews, and here are the top 7 most asked front-end questions you should know if you want to pass an interview as a senior front-end engineer. In this video, we will also show you what's the number 1 mistake most front-end developers make in technical interviews, the most important thing to focus on if you want to stand out in a front-end interview, and if you stay until the end, we will reveal a sneaky trick to take your front-end interviews to the next level. Let's go. Question number 1. What is the difference between cookies, local storage, and session storage in the browser?
Okay, so basically cookies have a limit in terms of storage. It's around 4 kilobytes. They are server and client side. So server and client, that means whenever you make an HTTP request, you'll send the cookies through. That's why they're great for authentication, especially if they are HTTPS protected. And they're great for storing things like the token or anything you want to share between, kind of share state between server and client, and that you want to synchronize seamlessly because they get sent over by the browser. Local storage, the limit is much higher. I do not recall how much, but it's much, much higher. It's persisted indefinitely, so persisted forever, versus cookies that have an expiration date. And it's great for storing application state. If you want to persist any of your state, whenever, let's say you have some user state that they close the window, but you want them to still have it. Like, let's say the setting of the team, if you have a dark team or a light team. And then session is a bit more peculiar because this one does get deleted when they close the tab or the browser window. So it's not used that much, but you could use session storage for things like whenever you want to store the form inputs, one of these checkout pages, and the users, they start typing it out, and if they refresh, you do not want them to lose that. So you can store this in session storage. It gets automatically deleted when the users close the tab, so you don't need to care about cleanup.
Cool. Now we're going to move on with question number 2. If you are setting up a new front-end application, what are some optimizations you would put in place in order to make it more performant? And also maybe you can briefly explain each of them.
Sure. So can I use a module bundler? Is it a modern front-end application? Could you give me more detail?
Yeah, let's suppose a React application client-side rendered, let's use Webpack as a standard, as a module bundler, and feel free to pick it up from here.
So we probably need to bundle this in a bundler. And probably the first thing you want to do is to polyfill the code. So number 1, I will definitely polyfill. That's just because you do probably want some modern features of JavaScript, and not all the browsers support this, and we don't want to worry about it. So I'll probably bundle our code, and number 1, polyfill it, which will increase the size of our bundle, but it's just necessary.
Can you explain in 2 seconds how polyfills actually work?
Basically, you look for different language features in your code, like promises or the spread operator, and then you check your target browsers, like if we're shipping to Internet Explorer 11, and then you figure out, okay, does this browser support this JavaScript feature? And if it doesn't, then you replace that with some function written with JavaScript browser supports. So it's basically kind of replacing or adding new code to your code base to support or replace features that maybe your target browser doesn't support. So we polyfill our code. That's number 1. Number 2, we bundle it together. So we're going to have this big bundle. And the number 2 thing you want to do is to apply compression. So we don't want to ship a JavaScript file. We want to ship a gzip file, and then with content negotiation indicate to the browser, hey, this is a gzip file, and then they'll take it, decompress it. And so here we decrease probably 70% the payload over the network. So we increase the loading time. And there's a couple more optimizations that we can do traditionally in JavaScript. This is kind of uglify the code and minification. So these two, they are both kind of code optimization, and they take code we written and kind of remove new line characters, and they replace variables. Like we usually have these long variable names. They replace them with very small 1-letter variables. It's basically transforming it in code you cannot read, but it's slightly smaller than the initial file. And it's okay because the machine doesn't really care. The browser doesn't really care how we write our variables. They can just execute it. But because we do all this, we also will need to emit some source maps. These are basically extra files that will map the source code to the code we actually distribute. And so whenever we have a bug in production, you'd be able to know in your source code which is the line of code where that exception happened. If you don't have source maps, you cannot debug in production. Does it make sense so far?
Yes, 100%. We have to uglify this in order to minify it, but then it's just machine readable. So we need a source map for the developer to be able to debug this in production.
Yes, exactly. And all these optimizations you could do with Webpack, or if you're using something like a more modern bundler like Vite, they will come out of the box. So they all happen under the hood. And then number 3, I would definitely look into code splitting, just to make sure we only ship the JavaScript necessary for the initial load, and then we can lazy load or defer the JavaScript that's not strictly needed for the initial load. So that would be my third optimization when it comes to JavaScript. Now, this is at module bundler level. So all this is done inside the module bundler. Once we have the bundle already built, I would also add more optimizations down the road, like maybe a CDN, optimizing images and fonts and whatnot.
Awesome, makes sense. Now, what about tree shaking?
Oh, that's a really good question. So that would happen by default in Webpack and most modern module bundlers. We just got to make sure we're using the right modules. So we need ES6 modules if we do tree shaking in our code.
Amazing, Bogdan. Now, we're going to move on with the third question, which also has to do with performance, but it's more focused on when we have big assets. Okay, let's pick images. The question is, you are building a front-end application with very big images. Maybe it's an e-commerce store. Let's imagine that, very high definition pictures. Right? How would you optimize this for maximum performance?
Sure. Yeah, images are always tough, especially because designers don't necessarily want to compromise and they just want these big images normally, like a header and the footer, and that takes a lot of work to actually make load well. So I'm imagining we have maybe one of those big images or product images maybe. So how can we optimize that? Well, size matters. You really want to ship the minimum size that you can. So you don't want to ship a 3000 pixels image and render it as a 800 pixels element. So here you want to ship the minimum. Now the minimum means, of course, you want some sort of clarity. Like you don't want to show pixel stuff. It's just going to be very low quality. Once you have the size, like dimensions, I'm going to call this dimension. You want to look into compression, and you can still also do image optimization. I'm not going to get too deep into here, but the tools I worked with can remove metadata from the image, or you can modify what they call the color space to include less colors. The image looks a bit less vibrant, but it contains less data, so it's smaller. And then, of course, I would always use the WebP format. Whenever we ship to the web, it's the most recommended for web performance. PNG, it's okay, but WebP is the best. You want to put all the images in a CDN, so you have the right caching policies on them. And then you can also look into lazy loading images. If they don't need to be visible on the initial load, you can either lazy load in or load on scroll. This is getting very popular these days, to load images as the user scrolls. You got to be careful there because those things might affect SEO, but in general, they're okay. And because you do lazy load, but we do not want to have any cumulative layer of shift, you will need to specify width and height. And of course, you can use the source set attribute, to ship different images depending on the viewport on like the device. So basically you can ship a different image on mobile and then load different image on desktop. It's pretty much the same image, but you can create smaller thumbnails of that image automatically. And usually CDNs offer that out of the box, like modern CDNs would create the thumbnails for you and then give you a snippet that already includes source sets. So your image is as small as possible in the different devices.
Awesome. Understood. Wow. There's a lot of different ways you have to deal with images. Let's understand a bit what these two questions that Bogdan just answered have in common. Right? And what they have in common is that they both deal with performance challenges in the front end. You see, the reason why most front-end developers struggle with technical interviews is because most technical interviews don't actually test you on your core front-end skills, like building components and writing code, but on secondary skills, like performance, optimization, testing. Those are exactly the skills that most junior and mid-level developers ignore because they don't come up in their daily work, which is why no matter how hard they focus on writing the perfect code, they don't do very well in technical interviews. And here is one quick way to get your front-end interviewing skills to the next level. Spend as much time testing and optimizing your front-end application as you spend building it. Okay, do get familiar with debugging tools. Do get familiar with the performance tab. Okay, which gets me to another main point of this video. One topic that you have to start accounting for if you want to really get good at doing front-end interviews, it's front-end. We won't have time to dive into this in this moment, but if you want Bogdan and I to make another video talking about it, just let us know in the comments. Now we're going to move on with question number 4. Bogdan, how would you manage code quality in a large-scale front-end application? What tools and practices would you use?
For code quality, I would probably start with a linter. And so you want to basically catch small issues, make sure everybody writes the same code. So you want to have prettier, maybe ESLint set up. If you're using TypeScript, have the TSLint set up. It just takes off a lot of the work and communication because everybody writes code in the same style. After that, you do want to have a layer of unit tests and ideally some E2E tests for sure. And then finally, I would have something like a dependency scan. Ideally, you also have in your linter something to scan for AI11E, which stands for accessibility. Mm-hmm. So we're taking care of code quality and style. We have accessibility covered. We have testing. We have a dependency scan to tell us how our dependencies, node modules especially, can be very vulnerable to different attacks. And finally, maybe you want to also add something like Lighthouse or Sentry to your pipeline, and they will tell you how your core web vitals change, basically how your web performance changes over time. So if by any chance we make any mistake with a big image, like we mentioned before, or we add fonts, we immediately see the effect of that on our web performance and we can fix it early on. So
cool, Bogdan. Now we're going to move on with question number 5. What is an XSS attack and how can you make sure that your front-end application it's not vulnerable to such an attack?
An XSS attack. So I guess that stands for cross-site scripting. So let me do it really quick. So basically, as I recall, in XSS, the attacker, it's somehow persisting some sort of JavaScript code into our database, and then our users are, because they fetch things from our database, they can run that. A good example will be Facebook. I think it happened to them back in 2006 or something. Someone was writing comments on famous posts as JavaScript, and whenever you load that post, you'd render that comment, you'd actually run that JavaScript on your machine. So what does this mean? It means basically I could actually send over the network in that JavaScript, have a fetch with a post and send your password and credentials over the network to myself, for example. So yeah, that's basically the attack itself. If you want to prevent this in the front end, number one thing, you want to sanitize input. So sanitize input, that means the attacker ideally cannot persist JavaScript code into our database as comments or text input. So we're able to somehow detect that and remove that. And we don't want to add JavaScript to our database. But even if they manage to do that somehow, we could actually make sure we never render HTML or /JS from the user, or that we receive over the network. It's a bad practice. And so one of the things, if you ever use React, you probably know of the dangerously set HTML, and you want to avoid this at all costs, because this means you're giving code that you're not aware what it does to the browser to render on your user browser. So I would avoid this as much as you can. Basically, two things: sanitize the input and avoid just directly rendering JS or HTML that you receive from the backend into the front end.
Now, question number 6. Can you explain quickly how a CDN works? What are some disadvantages, advantages of having a CDN?
Sure. I love CDNs, by the way, one of the best tools in the front end. And basically what it does is just it's a content delivery network. So there's a network of servers that will replicate our website. And whenever somebody is accessing it from a geographical location, rather than getting the assets from our server, like the HTML, JavaScript, and CSS, they would get them from an edge location of the CDN. So imagine this is our website, and I create a CDN distribution. Let's put it in yellow, and I spread it over the globe. If I have a user over here, let's say it's over here, that's my user. So the user gets the asset from us versus the user getting it from the closer location to them. The way this is done, it's with a DNS table that routes the user based on latency. So they would get the asset from the location that's closer to them, basically. And yeah, they're amazing. They're really easy to set up. And I would say it's a must have for pretty much any client application, any front end
What's the
application.
most now that we are here? What's the most common provider you use when you want to set up a DNS for your React apps, for example?
I would probably use AWS CloudFront if you are on AWS. I used this one a lot in the past, but you can also use Cloudflare. They are very established, very well. Cloudflare, totally recommended. So I use both of them. I used Azure CDN too. They can all do the job, but those two I found very easy to set up.
Cool. Awesome. Now we're gonna move on with the final question in this video. Very important question, especially in front-end architecture. Go into the level of detail you want. But the question is, what are micro frontends, and when would you use this kind of front-end architecture?
So typically we'd have a front end like this one right here. Imagine we have different components. I have a header. Let me change the color. And then maybe I have like the body of the page that shows maybe a product. And imagine here we have some sort of checkout information. Let's put that together. So this is our web page, and works pretty fine when we have a smaller team. But as we add more and more people to the team, it will be harder to contribute on the single front-end monolith. So as you get past maybe 30 front-end engineers, we have a huge amount of people in the front end, it makes sense to split those individual parts into independent applications. So this one has their own domain, this one has their own domain, and this is another application. And there is a shell, which is the main one here, the green, that puts them all together. It's responsible for authentication, shared state. And now, because you have this, you can actually deploy, for example, this one independently and have a team working only on this one. Then you have this one and you can deploy it independently. So it allows you to really separate development teams, and you can make basically the development faster, but you do pay you pay a price of complexity in the front end because they add a lot of complexity to your setup, and you need very complex tooling to make something like this happen.
When does it make sense? What's kind of the criteria? When did you, if people come to you as a senior software engineer and they tell you, hey, we have a big monolithical front-end application, we are thinking about breaking this into micro front-ends, what would be the criteria for you to consider such a move?
So micro front-ends are mostly good when you want to split your organization. So you need to split people into teams and they want to work separately. Because we're distributing our system, you always pay the price when we distribute systems. So all of a sudden you have things that are very hard to do, like sharing state. And so I wouldn't pay that price until you have a very good reason to. And the only good reason to is that you have so many people working on the front end and you start having issues with the deployment pipeline. For example, it takes very long to deploy the app. Several teams, they block each other. So imagine one team deployed, now they need to roll back. This is the only front-end monolith we have. The other teams are waiting and they cannot push features. So it's more of, okay, we need to make the organization faster and we need this technology to enable us to work separately and to work in parallel. But you do need a certain scale. So I would say most companies probably have done this too early, and they realize, okay, this is actually a lot of complexity. We have all this complex tooling. Now we're spending so much time in meetings, assessing all this. So you need, if you're in retail and you have a big team of developers, I'll definitely consider it. But if you are building smaller websites or smaller applications, I wouldn't even bother about it.
Awesome, Bogdan. Yeah, micro frontends are quite complex to handle and manage, but I would say also a must topic for any front-end engineer that wants to get to senior. 3 things I want you to do. First, if you have any technical interview questions that you want Bogdan and I to answer in one of those videos, just drop it down in the comments. Second, if you are interviewing right now and you want to find out what your technical level is, what are some technical gaps you should fix before you go to your next interview, then check out the free technical assessment we've put together for you. And third, it is proven that developers who have a mentor are almost 5 times more likely to get promoted and earn more. If you want Bogdan and I to personally mentor you so you can become more confident and competent and get to that senior JavaScript developer position, then you can book a chat with me and see if we could be a fit. Thank you, Bogdan, and we will see you in the next one.